Hi everyone. Today we will use AI help us do mock interview for system design. And also in this case, I will use the GPT. And in the video description, you can find that the prompt I put in the GPT as the personalized. You can use this prompt in other, for example, Google Gemini or Cloud anything or Olama us you can use the AI. So we will use AI to help us do mock system design interview, and also at the description of the video, you can find the link to our Discord group that you can find your interview partner to do mock system design interview to each other in this Discord. And also we have other some resources about what books you can read at the description. You can also find that. Okay, so today we will use the book, the lecture, the first case is about that we are going to designing a tiny URL. And also, I think the easy way is that we can just use the voice mode. Okay, we just wait him for loading.
Keep
Who
going.
is who is our target audience? Is there B2B or B2C? Who
Good
is our
question.
yes?
Let's assume it's B2C initially, but with a vision to expand into B2B for enterprises needing branded links and analytics. How does that shape your approach?
Okay, now you say that we are going to B2C first. And so first I want to asking some questions that people will use that frequently. And how many users, such as you can give me an estimate MAU or DAU for verify that I need to do understand that what's the market size of this product.
Great line of thought. For B2C, let's estimate a starting point of 100,000 monthly active users, MAU, within 6 months post-launch, targeting general consumers, marketers, and content creators. How would you refine the market analysis to verify if this estimate aligns with reality?
Okay, now we know that there's some numbers of the users, and next I want to ask in what's their features. For example, they will put a long URL and they will get a short URL, and what the length you prefer that how short URL we need to return.
Typically, shortened URLs are around 6 to 8 characters long after the domain, balancing brevity with uniqueness. However, scalability needs careful thought. Longer keys might be needed as users grow. How would you ensure the system efficiently handles collisions as the database scales?
Okay, so there will be some about from 16 to 8 numbers of the output letters. And if the user is scoring that, maybe we will provide longer of the items. And what will be in the our return show the URL? For example, will it return symbol or numbers or uppercase or lowercase? And what kind of the possible output will in our shorten URL? I will recommend that we can just combine as the uppercase, lowercase, and numbers, and we don't provide symbols.
Combining uppercase, lowercase, and numbers is a solid approach. It gives a wide enough character space without complicating the user experience with symbols. The URL would be short, easy to share, and user-friendly across platforms. How would you ensure the security of these shortened URLs, though, especially with public sharing and possible abuse?
Okay, there's why I asked in the earlier. If we are facing a B2B case, maybe we need a security problem. But if we are using B2C, I think anyone can fetch any short URL to get anything. So I think we don't need a security issue here.
That's a fair point for B2C. In this case, the primary concern would be minimizing spam or abuse rather than security in the traditional sense. To address that, What strategies would you consider for preventing misuse, such as malicious redirects or link farming?
Okay, I think we don't care about that first, and I need to ask him more about the features. So that we are focusing on B2C and not for B2B, and maybe that about that we can thinking about. I want to ask. It's about that. Is this system which one more prefer? It's about that. There are two major feature. One major feature is consistency that a user can always keep this URL alive. And another thing is that availability is that user can always fast get the result. And in my view, that because we are going to use B2C instead of to B2B, I will recommend that we can focus on available first, that user can get fastly as soon as possible. And if the URL is dead, they just generate a new one. I think they don't care about that to generate again.
I see your reasoning, and focusing on availability makes sense for a B2C audience, especially if the trade off between consistency and availability isn't critical for most users. If the URL is temporarily unavailable, they can just regenerate it. This approach keeps the experience fast and simple. How would you balance system resources to ensure high availability, particularly during peak usage? Would you lean
Okay.
toward horizontal scaling or other methods to handle traffic spikes effectively?
Okay, I will asking another case. This case is about that. It's not a case. I want to asking about next feature. It's about that we are talking that user will enter in long URL to get a short URL, and maybe this will fail after a period of region because we assume that. Only few users will keep reuse that short URL. So, how long you want to user to keep that URL? For example, he can keep this result for months or years.
For B2C, a reasonable approach would be to provide a retention period of 6 months to a year, with the option for users to extend it. After that, the link could be expired or archived. However, this raises the question, how would you handle the trade-off between storage cost and user experience? Would you opt for a cleanup process or give users more control over the retention period?
Okay, I think in the early stage that we do many asking case about that we can start doing to record do some take note. So first we are doing shorten URL case system. And also, we will have asking about the target audience. So our TA will be okay. Maybe I need to remember that it will to in the early stage we have asking about what's the MAU and DAU, and it's talking about that we will have one 100,000. It's relatively not large. So we can just the MAU or DAU. Is that MAU or DAU? So it's talking about the MAU you about this. It actually not big. Maybe we can handle this in higher scale or we can thinking about later. So TA is that we are doing about usual customer. So about the basic features. Functional basic features. It's about that user will get a long URL and get short URL. It's approximately 6 to 8 length size shorten URL, and also it just will be the uppercase plus lowercase plus numbers. So the combination will be the maybe it's about 25 plus 10, so it will be 62 multiply 6. It's our space. So in generally, we will do a short calculation about this. It will be 65 approximate about these numbers of what we can doing. And also we will talking about that it's about storage. Storage is that the time storage about the URLs will be, he will just say it will be 6 to 12 months. So also it will have some features. What we asking about our features and shorten URLs. Okay, and yeah. Also, because we are carrying about it's the B2C, so this system will be the usage available major availability major. So what's the availability? Okay, this will be the availability major. So until here, I think major features we understand, and start we can calculate about something. It's about the QPS and storage. It's about features, non-functional features. It's here's more like non-functional features. I think we can just use this. Okay. Also features will calculation about QPS. It's about because the MAU will be 100,000, and also we will estimate some about ratio. We will estimate DAU ratio. It's maybe will be 20%. It will be lower or maybe 50%. Will be the DAU measures. And also we'll assume that for each users, they maybe will generate 10 per day. And also we will divide by the QPS will divide to for daily seconds. And also we can get this QPS. Well, output will be it's relative low, 1.5 per second. 1.5 query per second. So it's relatively low. But the problem is our storage. For example, we will store 6 months. So we can just assume 6 months plus 30 days. This will be the days. And for each days, we will have the users will be these our users and per day. So because we calculation this will be 227 these items, total items, and for each items and we maybe need to assign some for each items length. Also QPS, we will assign some that it's a peak. Maybe peak ratio, we assume that there will be 4 times, so they will have 6 queries per second. Yes, because the user will be relatively low, so I think the it's not so heavy. Yeah. And item average length, we will assume that maybe they will have 100 characters per URL, and they will convert into maybe 6 to 8 lengths for this case. and we will multiply it for length and adding some meta information. For example, we will put 100 meta information. Maybe will be low, maybe just for 20 for meta information. We just keep as short as possible to make the information. So totally storage will be this one plus this one plus this one. This will be kilo mega GB, some GB. So it's relatively low and it's relatively simple. It's not so large. It's really right. KMG, yes, just 13 GB. I think it's relatively low. So if we want to handle more users, for example, there will be 100 millions. They will be if in current user, and also in the future, maybe they will grow. Maybe they will become 1,000 times. They will become 13 TB. This is still easy to get that information. So also we can post the list to the AI to show that this is our discussions. Okay, and also do you think this number is fair? Okay, yes, he's talking about that scalability or since usable spiritual and store. And okay, we can start chatting to AI. So as the calculation that you see that the storage it's relatively not large. For example, it's just 13. Even they have 100 million users per month, we still only need for example, it's about just one disk. It's also so it's almost we can almost handle just with few disk. Do you think this is common?
Yes, you're right that 13 gigabytes in the current scenario is relatively small. And even as you scale to 100 million users, the overall storage requirements wouldn't be overwhelming. With modern storage solutions and distributed systems, it's very feasible to handle even terabytes of data across just a few disks, especially with solid state drives, SSDs, or cloud based storage solutions that scale efficiently. For comparison, most large scale services focus more on scalability and redundancy than just raw storage. It's common to distribute data across multiple servers or use object storage like AWS S3 for easy scalability without worrying about individual disk limits. Would you also factor in the potential need for redundancy, backups, or high availability in your storage design? This might influence how you set up your infrastructure.
Okay, in the first, we will focusing on a simple structure of the design, and then we will talking about scalability and security, or such as fault tolerance in the future. So first, maybe we will do a simple case about the system. So in the beginning, because assume that there are many users, so we will have a load balancer as the basic user will first attach, and then they will attach to the servers, and also these servers will have processing. It's if it's about that user, it's using a long input. It's a long input, and our processor will process into short URL to return. And if users it's using their short URL, they will get the return of the long URL. And maybe we can assume that the read and write ratio will be 30 ratio to 1. 30 to 1, that means for each users, they use one shorten URL, they will reuse it 30 times. Do you think this is a fair assumption?
Yes, a 30 to 1 read to write ratio is a reasonable assumption for a URL shortening service, especially considering the nature of usage. Once users shorten a URL, they will likely reuse it multiple times across various platforms, whether in social media posts, emails, or promotional materials. This read heavy behavior is typical, as the majority of interactions with the service will be retrieving the long URL from the short version. Given this, how would you design the system to optimize for the high read to write ratio? Would you focus on caching for the reads, or are there
Okay, so it's talking about something. Okay, so we can starting do our because we understand that input and output, so we can doing our system design. First, maybe we have many users. Yes, they are users. And also, we will have a load balancer. This will be our load balancer and our user, LB. And we will have our backend server. So, backend server, because they will have load balancer, so they will have many machines. And they will have two cases. First case is about write. It's about writing, write. And they will be our DB. Okay, so here we need to have something discussion about this, so we can go to the AI again. Okay, we can just use the talking mode. Okay, I have the thinking about that because we are using the long URL convert to short URL, and for the user query that they will input short URL to get long URL. I think use rational DB such as SQL. It's relative fair, right?
Yes, using a relational database like SQL can be a fair choice for a URL shortening service.
Okay, so we got the yes. So we just rational database, rational database such as SQL. So they will have a write, and also they will have a read case. Okay, so because the write and read will have a different overhead, so for this we will have a cache about for read. It will be encode. We can call this encode, and this will be the decode URL. Okay, and the cache will be if the hot. If the hot, we will put into the cache. And also, if the in the future the extension will be a large, maybe we can do sharding. In the future, okay. Okay, in this design, we can talk to the AI now. Okay, now we have a design graph. Currently, we will assume that there are users, so they will pass to the load balancer first. And then if user is trying to write the database, that means we will encode the URL into short URL. We will have our backend processors, many machines to parallel process it for the scalability, and they will encode into the related rational DB such as SQL to store to a storage. And because there are many URLs, maybe we can do some, for example, sharding for better performance and scalability for different users. And also, if users is trying to use the decode path, that means they will input a short URL, shorten to get long URL. They will do a decode, and if this is fetched many times, it's better to have the cache. So we will have a read-only cache for this case. Do you think this is a better design?
Yes, this is a solid design, especially for scalability and efficiency in handling both read-heavy and write-heavy operations. A few things stand out as strong choices. One, load balancer. The use of a load balancer at the entry point to distribute traffic across multiple servers is crucial for managing scale. It ensures high availability and responsiveness. Two, parallel processing. Having multiple back-end processors handling the encoding process in parallel is a great way to distribute the load. This will be important as your user base grows, ensuring the system can handle large numbers of URL shortening requests without slowing down. Three, sharding. Implementing sharding in the relational database is a smart approach. By splitting the database into smaller chunks based on user segments or other criteria, you reduce the chances of performance bottlenecks and improve scalability. Just be mindful of how you plan to manage cross-shard queries or data consistency if you scale up. 4. Read-only cache. Caching frequently accessed short URLs is absolutely the right strategy, especially since reads will vastly outnumber writes. Redis or a similar caching layer will reduce load on the relational database, making the lookup process faster and more efficient. One thing to consider is cache invalidation. If you ever need to update a URL or modify the mapping, you'd need a strategy to ensure the cache is correctly updated to reflect these changes. Would you also think about introducing metrics and logging at each layer, e.g., load balancer, backend processors, cache, to monitor the performance and health of the system as it scales? How would you handle failures or downtime in this architecture?
Okay. Wait. So now we are going to talking about fault tolerance. Scalability is finish and fault tolerance. There are maybe possible solutions. It's about that the major will be the system. It's about that about the calculation part. It's about the backend machines. Of course, they will have replications of calculation machines, and also they are possible of the DB database. It's possible to have many solutions such as replications, and because the user it's because we are using to for the B2C part, so the fault tolerance is relatively high because if we want to, okay, I think we should just in a talking space. For the tolerance part, that for the calculation part, the calculation machine about compress and decode, that this is more like the lambda calculation. So it's easy to increase machines or decrease machines based on the user's usage. So I think here's more easily to handle the fault tolerance. And about the DB part, the database, because we are facing to B2C case, it's that if the some such as the disk is that the user need to they just get a fail of the decode part, they just encode again. So if we want to do such as replication, for example, read. For replication for the safety of the data will be more more expensive. So this is well based on how security we want, and also we want to measure how much our budget for this system. So I think for our cases, we can trying maybe lower budget, maybe fewer. We don't really need to very care about fault tolerance because we are not facing to B2B case.
You're right in your reasoning. Since you're focusing on a B2C scenario and the primary user interactions are encoding and decoding URLs rather than critical transactional operations, your approach to fault tolerance can be more flexible. The Lambda-like architecture for the calculation part, encoding, decoding, is a good choice as it allows for elastic scaling, adding or removing processing power based on demand. This approach also means that individual node failures won't significantly disrupt service, as new nodes can be spun up easily to handle the load. For the database, considering the trade-offs between cost and reliability, it makes sense to take a more cost-effective approach. Since you're not dealing with sensitive data or high-stakes transactions, like in a BB case, replication and highly redundant storage may be an overinvestment at this stage. If the system can tolerate occasional failures, i.e., users simply re-encode URLs if something goes wrong, then opting for a more basic setup like single node databases with backups or using cloud services that offer automatic recovery could be sufficient for now. One thing to think about though is user experience during downtime. Even in a B2C environment, failure to retrieve a short URL can lead to frustration. Would you consider implementing a simple fallback mechanism like a delay or retry strategy before users would need to re-encode? Overall, you're striking a good balance between cost, simplicity, and reliability given the use case. How would you monitor and measure the system's health over time as it scales?
Okay, now it's calling about that the fault tolerance is still important because they will have issue about 以后都 spelling this fault tolerance. Fault tolerance, fault tolerance, fault tolerance. Because this is care about user experience, so it's about user experience improve. That frustrated maybe user will want to success, so they will maybe have some such as a fallback strategies, or even such as duplication. Yeah, it's able to restore storage, but the list will be a higher cost. Yes. So I think the major finish it's our self mark system design interview with AI with a shorter demo. So in the future we will try to make this more. And today I think we can just make this a simple case. Yeah, thank you for watching.